In this video, I'll be completing the June 2016 series, Paper 1. For any students not from Bryn Hafren, these papers have been made from the legacy specification using foundation and higher questions that are applicable to the intermediate tier. Students should remember that these questions are to be completed with no calculator. Question 1 is on sequences. Write down the next term in each of the following sequences. It's advisable to check the gap between each of the terms in the sequence to start with. The gap between 15 and 24 is 9. The gap between 24 and 33 is also 9. And 33, 42 is also 9. So this sequence is increasing by 9 each time. So adding 9 onto 42 gives me 51. The next sequence, the gap between 8 and 9 is 1, the gap between 9 and 11 is 2, and the gap between 11 and 14 is 3. Now this is also an add-in sequence, but it's not adding the same increment each time. It's going up by 1 more as each term progresses. So we'll add 4 onto 14 to give us 18. Next question. Write down the value of the 8 in the number 56182. Now it's advisable to say this number out loud, 56,182. Because I said 80, that's the clue. We know in our place value system that HTU, hundreds, tens, units, would be the 182 on the end. So for the mark on this question, we can either write tens or write 80 in figures or spell 80. We are not allowed to write 10. That's not accepted, but we need to show that we understand that 8 is in the tens place. Part C. Write 13 over 25 as a percentage. To convert your fractions into percentages, we need them to be written over 100. Now 25 goes into 100 4 times, and 4 times 13 gives us 52. So 52 over 100 is 52%. Write 0.51 as a percentage. Well, multiplying by 100 will turn our decimal into a percentage, but I'm sure you're quite confident that that is 51%. And then write 55%, 0.51 and 13 over 25 in ascending order. That means small to big. So our smallest is the 0.51 because that's 51%. Next one is 13 over 25 because that was 52%, and then 55%, the third one they've given us, is the largest. Find an estimate for the value of 42.2 times 11.3. Show all your working. Now this statement can confuse because we associate working with something like the grid method or long multiplication, but because the keyword here estimate means we want to get a rough idea and we want to make these numbers easy enough to do in our head to get a rough guide of what the answer is. Now I'd be inclined to go for one significant figure here and call 42.2 40 and 11.3 10. Now you do not have to show any kind of grid method. That is your working mark, showing how you decided to round those two numbers. 40 times 10, 400 for my second mark. You will be assessed on the quality of your written communication in this next question. On the new specification, this is shown with OCW, and there are 2 marks available for communicating properly. Now, a quick scan of this question shows that we're dealing with money, so I'm going to be very conscious to put pound signs on any of my figures that involve money, and I'm also going to explain what I'm doing at each point. Now, this question, as you can see here, is worth 6 marks, so it's 4 marks for the maths and 2 marks for the communication. Ali, Claire, Nick and Sam go out for a meal together. The meal costs a total of £40. It gives us the cost of the meals from Ali and Claire, what they've paid. This next bit we'll deal with in a moment. I'm going to start by adding the £9.35 and the £8.85, remembering my pound signs. £18.20. I'm just going to put in brackets here Ali and Claire, so that I'm showing that I know that's what they paid. If the total cost was £40, I know I can deduct £18.20 away from the £40 to show that £21.80 must be what the other two people pay, Nick and Sam. Now the next few lines say Nick pays £1.50 less than Sam, or Sam has paid £1.50 more than Nick. So with this £21.80, I'm going to take away the £1.50, the extra that Sam paid, to leave me with £20.30. So visualize Sam putting down that £1.50, and then if that £1.50 extra has been accounted for, Nick and Sam must pay the balance equally. So £20.30 is what's left, and split that between two for £10.15 each. So Nick pays £10.15. Question 3a, simplify. 6c take away 4c plus c. 6c take away 4c is 2c. Add the extra c gives me 3c for 1 mark. Use the formula t equals 7a minus 3b minus bc to find the value of t when a equals 3, b equals 4, and c equals a quarter. So what I'm going to do, I know that 7a means 7 times a. If a is 3, I'm going to deal with that first to know that this is 7 times 3, which is 21. b is 4, which means that 3b is 3 times 4, and that gives me 12. And c is a quarter, and 8 times a quarter is the same as a quarter of 8, which is 2. Now I found the value of each of the terms. What I haven't dealt with is the fact that there are subtract signs in between each of these. So 21 take away 12 will give me 9, and take off 2 means the full value of the expression is 7. Part C. The x and y values of the coordinates of the points 4, 16, 5, 20, 6, 24, and then the ellipsis here shows that this is continuing to x, y, all follow the same rule. Write down the rule connecting x and y. Now the temptation here is to write something like plus 4, because you can see that 16, 20, 24 is adding 4 each time. But if we gave a random x coordinate like 10, how would we know what the y coordinate would be without going back to the beginning and adding 4 constantly? Because they say connecting x and y, we are looking for how does the x value become the y. How does 4 become 16, 5 become 20, 6 become 24, etc. And a quick think of your times tables will show that we're talking about multiply by 4 So I'd write something down straight away to show the examiner that I know that is times by 4. And the most sophisticated way of presenting this then is to say that whatever the x coordinate is, the y coordinate is 4 times as big. Next we've got a formula. A washing machine engineer takes 1 hour 15 minutes to service a machine. The cost is found using the following formula. Cost equals £40 times the number of hours worked plus the total cost of parts. Calculate the cost for servicing 6 washing machines when the total cost of parts is £87. Now I know this total cost of parts there because it's given to me, 87. But bizarrely on this, I can't substitute 6 into this equation because it doesn't exist. It's not saying the number of washing machines, it's saying the number of hours worked. It wants me to find the cost, but somehow I need to turn 6 into the number of hours worked. And I need to use this bit of key information at the top, that one machine takes 1 hour 15 minutes. So if I know that one machine takes 1 hour and 15 minutes, I know that 2 machines would take 2 hours and 30 minutes just by doubling. Now if I doubled again, I know that 4 machines will take 4 hours and 60 minutes, which you should spot is the same as 5 hours. So the cost of 6 machines could be this one and this one added together. So 2 hours 30 minutes plus 5 hours means that 6 machines is 7 hours 30 minutes, which is 7.5 hours. Now that is what needs to be substituted in here, the number of hours worked, 7.5. So I need to do cost equals 40 times 7.5 plus total cost of parts, 87. Now something like this could look daunting, but if you are prepared to partition your number 7.5, it's actually quite straightforward. You know that the 7 hours, 7 40s would give you 280, and if you worked for an extra half an hour on top of that, half of 40 would just give you 20. So 40 times 7.5 will be £300. Add the £87 on for the cost of parts and you get £387. Next question. The table below shows the times and heights of tides in Swansea Bay for a week in 2015. We've got dates running down the side here for consecutive days. And then we've got 4 separate parts of information: when the tide was out, when the tide was in, when the tide was out, and when the tide was in at different times throughout the day. So you can see on the 11th of March these times are chronological, and then it also shows us the height at these various times of the tide. So part A says the times of tides differ every day. When was the tide in for the first time on the 12th of March and then the 15th of March? Well, if I look at the 12th first, this 0345, 3:45 in the morning is when the tide was out. The first time that the tide was in that day is at 10 o'clock. So I will just write 10:00 in there. They're using 24-hour clock, so there's no need to write AM. On the 15th of March, when was the tide in for the first time? Now, we can be confused here. There's a gap in this line, and this is quite a tricky thing to combat. The fact is that this is blank because this time here is midnight 30, 0030, just half hour after midnight. And so what they've done is needed to put 0030 there to show that after the 14th of March, when the tide was out at 6 or 7 p.m, it came in at 0030. So they've put it there, and it's a trick because we'd be inclined to put 1317 as the first time that the tide was in. But look at these blanks, think why are they there, trace across, and we get 0030. How long is it between the times that the tides were out on the 13th of March? Well, the tides were out on the 13th of March between 0432, 4:32 in the morning, and 16:59 in the evening. So I'm working with 0432 all the way to 16:59 to find out how long it is between the times the tides were out. Now it's 4 in the morning to 4 in the afternoon, and that's 12 hours. And because these minutes are lower than these minutes, that'll work out quite nicely. If I added 12 hours onto 0432, it would give me 1632, and then I need another 27 minutes on top of that to make 1659. So it's 12 hours and 27 minutes. Part C. How much earlier in the day was the first tide out on the 11th of March than the first tide out on the 17th of March? So let's find when the first tide out was on the 11th of March. It was 3:07 in the morning. So I'm just going to write that here, 03:07. And on the 17th of March, again we've got this gap here, but it shows that the tide was in at 03:22 and the tide went out again at 09:39. So 09:39 is the first time that the tide was out on the 17th of March. The difference between these two, 3 to 9 gives 6 hours, and 7 to 39 gives 32 minutes. And then when was the highest tide? So we're looking for the biggest number in any of the height columns. So if we look at this column here, 6 is the biggest in meters. If we look at the next column here, that's surpassed quite significantly, 11.77 is our biggest height in meters. The next column is low again, nothing bigger than 1177, and in this last column there's nothing bigger than 1177. So it's this tide here, 921, which was on the 11th of March. An 8 cm by 3 cm rectangle is placed with two 6 cm by 3 cm rectangles to make the shape shown in the diagram. Standard WJC question, calculate the perimeter of the shape, and then part B, calculate the area of the shape, write down the units of your answer. Because this diagram is in centimeters, I know the area is two-dimensional, so I'm going to write centimeters squared to start off with to make sure that I gain 1 mark from this question minimum. Now, the first thing I need to do here is work my way around the shape, finding any missing lengths. This is the easiest length to see here. This is 6, because it's opposite this length here, and these are all rectangles. This length here and this length here, not so straightforward to see. Now it looks like that's half, but we can't just presume that it's 3. We need the proof that it would be 3. And for that, we actually need to look at this 3 here. Because if this distance from here to here is 3, then so is this distance from here to here, this dashed line. That's also 3. I'm going to write it on, but I'm going to put it in brackets because I want to make sure that I don't add it when I consider my perimeter. If the length of this horizontal length is 6 and this part is 3, then that's 3 as well in there. A little bit more challenging to find this length here. This entire vertical length is 8, and this length here is 3, and this length here is 3, so that leaves me with a length of 2 centimeters there, so that my entire vertical length of the shape adds up to this 8. Now when it comes to calculating the perimeter, I always recommend you put a little dot on a corner so that we remember where we're starting, because I need to now work my way around the outside of the shape, adding up all the lengths as I go around. So I'm going to go this way, so I'm going to start off with 6, add 3, add 3, add 2, add 6, add 3, add 6, add 3, add 8. And I know to finish then because I'm back at my dot. Now this has given you 2 marks because you've evidenced that you understand what perimeter is, and the examiner will be pleased to see this too because you've worked out this component length here. Take your time with this. 6 add 3 is 9, plus 3 is 12, plus 2 is 14, plus 6 is 20, plus 3 and 9 is 29, plus 3 is 32, plus 8 is 40. In the exam, I recommend you do that sum twice just to make sure that you've got it spot on. Now, area of the shape involves rectangles and squares in this case, so we need to be doing length times width, and I would write that down here again just to evidence that I understand, I know what I'm doing. It's no good just working with these figures up here because this shape is made up of overlapping rectangles, and if we worked out 8 times 3 and 6 times 3 twice and added them all together, we wouldn't be right because there's overlap happening in this section. So what I'm going to do is work out each part of this. For instance, this square here would be 3 times 3, which is 9, and that takes care of this little square. In a similar way, this here is 6 times 3, which is 18, because I've got 6 times 3. And on this rectangle then, I've got a height of 8 and a width of 3. 8 times 3, 24. Now the examiner will look at the diagram for workings as well. So now I can just write 24 plus 9 plus 18, add all these together. 24 add 9 is 33, plus 18, so add 10, 43, add 8 will give me 51 centimeters squared. The diagram shows the parallelogram PQRS in which QRS equals 48. The angle at R is 48. The line QT is drawn so that PQT equals 53 degrees. The questions below say find the size of angle X and find the size of angle Y. Now the important thing to note is that we are dealing with a parallelogram, and a parallelogram will contain Z angles, F angles and C angles, which of course add up to 180. So it might be appropriate to look for those at some point. But one of the easiest properties of a parallelogram to remember is that opposite corners are equal. So if this angle in here is 48 degrees, then the angle at the top is also 48 degrees. Now we can use our C rule, knowing that angles within parallel lines are supplementary, they add to 180, to say that these two angles will add up to 180 degrees. So 180, take away 48, a little bit of borrowing, will leave us with 132. So this angle in here is 132. And then this section, PQTS, is a quadrilateral with 360 degrees. So the angle X can be found by adding the three angles that we've got already for 233, and then subtracting 233 away from 360, and we get 127 degrees. So X is 127. Now I'm going to mark that on here as 127 because it can then tell me what the angle the other side of 127 is, because I know I've got a straight line, and angles on a straight line add up to 180. So by taking away, I end up with 53. And then to find Y, I've got a triangle here which contains 180 degrees. So 53 and 48 add together for 101. And 180 minus 101 comes to 79. So Y, this last angle at the top, is 79 degrees. You haven't got to worry about filling all the lines, all the space. The examiner is quite happy to look for your workings on the shape above. Okay, so next we have a travel graph. The graph opposite, which I'll show in a moment, shows John's journey by car from his home in Bangor to a roadside cafe and then on to Cardigan. And Cardigan is 120 miles from Bangor. Some general questions then. How far did John travel in the first hour? John was, on average, travelling faster before stopping at the cafe than he was after he left the cafe. Without calculating any speeds, explain how you can tell this from the graph. So we'll do these two questions first. Looking at the graph here, distance from Bangor in miles does go from 0 up to 120, and there's our stop at the cafe. This is the cafe here. So first question was, how far did John travel in the first hour? 12 till 1 o'clock takes me up to this point here. And if I lay my ruler across there, I see that I come to this point, and that's right in the middle of 40 and 60, so he travelled 50 miles. I'll just add him in here. John travelled 50 miles. Question 2 was concerned with working out whether John was travelling faster in the first part or the second part of his journey, and for that we need to look at the gradients, and I can see that the gradient of this line is steeper, so I know it was the first part, so I'm going to write before the stop, and the reason, steeper gradient of the line. And the next bit is quite tricky. John's friend Marcus sets out from Cardigan at 1 o'clock and travels at an average speed of 30 miles per hour to the cafe. Draw his journey on the graph paper. Now it's important to show that John is going from his home in Bangor to a roadside cafe and then on to Cardigan. And that means that when John finishes his journey up here, he's travelled 120 miles and he's reached Cardigan. So this is where his friend Marcus sets out. So at 1 o'clock, Marcus is in Cardigan. He starts there. Now the fact that he travels 30 miles per hour allows me to plot the gradient of his graph. So if he set out at 1 o'clock, by 2 o'clock he would have travelled 30 miles. So at 2 o'clock he would be 90 miles from Bangor. So I can plot that point on. It takes a good understanding of distance time graphs to be able to do that. Draw his travels at an average speed of 30 miles an hour to the cafe. So what I'm going to do is draw my line on until I get here, because I know the cafe, I'm just going to move that down a little bit, the cafe is here, so this is when he stops. Now what the graph shows here is that he's not at the cafe at the same time as John. John's already left. He's waited for a while, presumably he's not come in, and he's carried on his way. They would have passed on the road somewhere without knowing it. But Mark has carried on to the cafe to get here, and question D says, by how many minutes did Marcus miss meeting his friend at the cafe? Now if I come down to the bottom first, just by looking at any random part, I can see 1 o'clock to 2 o'clock there, so I know that that would be 13:30. And that means that 10 squares represent 30 minutes, so 1 square equals 3 minutes. Now coming here, I count the squares, 1, 2, 3, 4, 5, 6. There are 6 little squares in between the time that they were at the cafe, so I'm looking at 6 times 3 for 18 minutes. They missed each other by 18 minutes. You do need to be that precise on a distance time graph question. Okay. 9a, bearings. The diagram shows Pwllheli and Fishguard on a map of Wales. Calculate the actual straight line distance between Pwllheli and Fishguard and give your answer in kilometres. We've got a scale here saying 1 centimetre represents 15 kilometres. So first of all I'm going to join these two dots up so that I can see clearly the line I'm measuring. And I measure the line and I get 7.5. So I'm going to write down that my line is 7.5 centimetres. Now using the scale, I need 7.5 15s. There's nothing wrong with doing 75 times 15 and then fixing your decimal point, but we actually did 7.5 times the number earlier. I'm going to work out 7 15s first, which is 105, and then 7 halves, or half of 7, is 3.5. So altogether this is 108.5 kilometres. It then says, what is the bearing of Pwllheli from Fishguard? Now because it said from Fishguard, this is the place that I'm leaving, so I want to measure the bearing from north clockwise, which is quite a nice acute angle to measure. Now you are allowed of course to extend the north line, because I want to be able to see this line through my protractor. So I put on my protractor on the dot so that 0 is lined up along the line, and I've got an angle of 24 degrees. Now, seems too easy for a bearings question, and if I leave it like that, then unfortunately I'm not going to pick up the 1 mark, and that's because bearings are 3 figure. So I need to put 024 at the beginning. Question 10. Parallel lines. Zoom in a bit. We've got all manner of F's, Z's and C's, but a question like this is much nicer if we think about the idea of sort of circles, congruent circles featuring all the way along the traverse of the parallel lines. Now I'd start out straight away It obviously wants us to calculate the size of angle X, and it's not drawn to scale, so it's not a protractor question. If this angle here is 38 degrees, then so is this angle. And so is this angle, and so is this angle, and so is this angle, and so is this angle. Now, we could, by using angles on a straight line equal 180, or the full circle adds up to 360, we could work out these angles here. As it happens on this question, we don't need to. We'll see why in a moment. Next, I've got 113 here, so I know 113 is there. I know 113 is there and there. And I know 113 is there and there. Now, what I'm faced with, I've managed to work angles all the way down to this triangle at the bottom. Now, I am going to use angles on a straight line equal 180 and take away 113 from 180, because that gives me 67. So I know that that's 67 and that's 67. Now, what I've got here is a triangle with 67 and 38 and a missing angle in there. 67 and 38 adds up to 105, and subtracting 105 away from 180 leaves me with 75. So I know that this final angle in here was 75, and therefore this angle, which sits on a straight line, is 180, take away 75, which gets me back to the 105 degrees. So X is 105 degrees. Question 11. Maria sells ribbon. She has a 400 centimeter length of ribbon. Maria cuts off 3/10 of this ribbon and sells this piece to a customer. She uses 2/5 of the remaining ribbon herself to decorate a card. Then Maria cuts the ribbon that is left over into 3 equal lengths. What is the length of each of the 3 remaining pieces of ribbon? Now, this is like a little checklist with success criteria. Do this first, this second, and this third, making sure that you read it a couple of times to make sure you're doing the right thing. She has a 400 centimeter length of ribbon, and she cuts off 3/10 of it. So I'm going to find 3/10 of 400. 400 shared by 10 is 40, and 40 times 3 is 120. So a 120 centimeter piece of ribbon went to a customer. She uses 2/5 of the remaining ribbon. Now, if that 120 had gone, then 400 minus that 120 means she's left with a 280 centimeter piece of ribbon. She uses 2/5 of this herself. So 280 divided by 5. Now, I'm not going to risk getting that wrong. So I'm going to go to my bus stop method. 5 into 28 goes 5 times with 3 left over, and 5 goes into 36 times. I know that 1/5 of 280 is 56, and then I want to double 56 because of course it was 2/5, and 56 times 2 comes to 112 centimeters. Then Maria cuts the ribbon that is left over into 3 equal lengths. So at this point she had 280. She takes away the 112. No room for error. Let's make sure we get this right. We get 168. And that needs to be split into 3 parts. 3 into 16 goes 5, 1 left over. 3 into 18 goes 6. So 56 centimeters is the length of the remaining ribbon. Question 12, scatter graph. A number of students took an examination. The heights of these students and the mark they each scored is shown in the scatter diagram below. First things first, let's take a look at the scale. No problem along the bottom, 1 square equals 1. No real issue up the y-axis for mark. 60 to 80 over 10 squares means that 1 square equals 2. Describe the correlation shown by the scatter diagram. Bit of a trick question because there isn't one. The points are all scattered across, so there's no positive trend and no negative trend. We're then given some information below. Charlotte scored the same mark as Dewi. Charlotte is taller than Dewi. Henry is the tallest student in the class. Dewi and Gareth are both the same height. And we've got to complete this table at the bottom to try and work out from these clues which point is which person. So I'm going to deal with the first clue. Charlotte scored the same mark as Dewi. So I'm looking for two dots that lie on the same mark line. Now this dot here is 24 and there's no other dot in line with it. Likewise this dot, this dot, this dot, this dot. It's up here that we see that we've got two dots that lie on the same mark line at 80. So I know that Charlotte and Dewi both scored 80 marks. Then I've dealt with that. Now it says Charlotte is taller than Dewi. Now because these marks correspond to the students' heights, which of course is why there's no correlation, because your height doesn't determine how good you are at a test. This dot represents the taller person and this dot represents the shorter person. Now if I read down here I get 163, and if I read all the way down here I get 145. So one of them is 163 and the other is 145, and it was Charlotte who was taller than Dewi. So 163, 145. Then it says Henry is the tallest person in the class. So I'm looking for the dot that's furthest right because that's the axis involving height, and it's this dot here. If I scroll all the way down to the bottom, of course you can use your ruler to draw lines. I see this mark here is 176. So Henry is 176 centimeters tall, and his corresponding mark is actually the highest in the class as well. Takes him across to here, which is 92. Our last clue is that Dewi and Gareth are both the same height. So if Dewi was 145, so is Gareth, 145. Now Dewi here, 145. There's also another one here, 145. It's quite a low mark. If I read across, I end up at this point here, which is 3 squares below 40. So that's 6 off 40 for 34. Question 13. Our recommended daily intake of food is often given in calories. A small bag of 20 almonds provides 160 calories, and it is recommended that Joseph's diet should contain 1,920 calories per day. Joseph eats a large portion of almonds one day. It is 25% of his recommended daily calories. How many almonds does he eat? You must show all your work in. Well, this is the thing that grabs me first. 25% of his recommended daily calories. So that's 25% of 1,920. So I'm going to use divide by 4 rather than half and half again to find 25%. 4 goes into 19 4 times, so 3 remainder. 4 goes into 32 8, and 4 doesn't go into 0. So we had 480 calories worth of almonds, and that fact is used and that fact is used. It then says a small bag of 20 almonds provides 160 calories. So I know that one bag is 160, so if I add another 160 on, I get 320, so it must be more than 2 bags. So I'll add another 160 on. 0, 2 and 6 is 8, 3 and 1 is 4, that gives me 480. which is the same as that. So he basically ate 3 bags. But the question asked for how many almonds does he eat. A bag contains 20 almonds, so 3 bags is 60 almonds. Next question, 14a, solve. 5x minus 65 equals 3x minus 17. Ultimately, my goal on an equation is to get x equals a number. So I don't like that number being there, and I don't like the algebraic term being there. So I'm going to eliminate them. First off, I can eliminate 3x by subtracting 3x. So 5x goes down to 2x. Minus 65 equals, the 3x is gone, minus 17. That's quite tricky, that little part there. And next I'm going to eliminate the minus 65 by adding 65 on. So 2x will equal minus 17 plus 65. Now that's a bit tricky. The subtraction 65 minus 17 can help you. Leaves you 48. So you know that minus 17 plus 65 must take you up to positive 48. And half it then for x equals 24. Slightly easier now. X divided by 4 plus 12 equals 28. So we can subtract 12 first from both sides. So x over 4 equals 16. Now the temptation here is to write x equals 4, because you know that 4 fours is 16. But that's not what's happening. X is being divided by 4. So to reverse that operation, I need to times by 4. And 16 times by 4 gives me 64. Expand y times y plus 8. Every term inside needs to be multiplied by the term outside. Y times y would give you y squared, and 8 times y would give you 8y. Remember, the method for solving an inequality is exactly the same as solving an equation. It's just that we're getting a set of solutions rather than one distinct solution. So I'm going to subtract 8 to start with. So 10x less than 34. Now at this point you might think you've gone wrong, but we've got a coefficient of 10 here, and when you can divide any number by 10 just by considering the digits and where the decimal point would sit. So we got x needs to be less than 3.4, which if we're looking at whole numbers would be the numbers 3, 2, 1, 0 and all the way down into the negatives. Draw a reflection of the triangle in the line x equals 1. Well, first of all I'm going to find the point where x equals 1, which is right here on this axis, and my line needs to run through that point. Now if I drew it there, that wouldn't actually create a line, that would be the axis itself. It reminds me that my line needs to run through that point. So it's this line here. Now this point is 1, 2, 3 spaces away from the mirror line, so the reflection is also 1, 2, 3 spaces away, and of course then the image is reflected. So we should end up with that. Part B, enlarge the shape shown by a scale factor of 2 using A as the centre of enlargement. Now scale factor 2 means everything is doubled. The size of the shape and the distance of the shape from the centre. Now if our centre here is A, I'm going to take a few corners in turn. I'm going to look at this corner first, down in the bottom. This corner is 3 spaces down from A, so the new corner would need to be 6 spaces down from A, which would be here. Because everything is doubled, I know that the base of this shape is going to be 4, because the base of the original shape was 2. And I also know that this length here, which was 3, is now going to be 6. I also know that this diagonal here is 1, so it's now going to be 2 diagonals. And at this point it might be a little confusing because this isn't spanning one square, this is going across 2 squares. So what I'm going to do, I'm going to plot this corner again. I'm going to go back to square 1. How do you get to this corner from A? Well, you go up 2 and you go across 1. So the new point from A will be up 4 and across 2, which takes me there. And then I'll see that when I join up, I'll end up with this. Don't be afraid that your enlargement shows an overlap. It's absolutely fine to have an overlap in enlargements. Question 16. Find the nth term for each of the following sequences. 15, 21, 27, 33. This is going up in 6s. So with the first couple of terms of the sequence, I consider the 6 times table. I know that I start my sequence with 6n. Now each time, to get from my times table to my sequence, I'm adding 9. So my formula is 6n plus 9. The next one, 30, 26, 22, is going down by 4. And I write the 4 times table to start off with. But what I notice then is it's not the same number needed to get from the 4 to the 30 each time. Because this sequence is going down, I need to consider the negative multiples, minus 4, minus 8, minus 12, and I start my sequence with minus 4n. Same rule applies. How do you get from your times table up to your sequence term? Don't think that it's plus 26, it's not. We need 4 to make the step from minus 4 up to 0. So minus 4 up to 30 is plus 34. The nth term of a sequence is 4n plus 15. Write down the value of the first term in the sequence that is greater than 100. You could do this by trial and error, by finding values of n. So you might try 10 to start with, 4 tens are 40, plus 15 is 55. But the most effective way is to set up an inequality. When is 4n plus 15 greater than 100? And if we solve our inequality then, by taking away 15, 4n will need to be bigger than 85, and so n needs to be bigger than 85 divided by 4. So 4 into 85, 4 into 8 goes 2, 4 into 5 goes once with 1 remainder. So 21 is a key number. Now if I do type in 21, 4 times 21 plus 15, 4 21s are 84, plus 15 is 99. It's just not quite there, and that's because of this remainder 1 bit. So in answer to the question, the first term that goes over 100 must be 22, which is just 1 more. In answering this question, you must show all your construction arcs. Use a ruler and a pair of compasses to construct an angle of 45 degrees at the midpoint of the straight line below. Well, to start off with, I'll just turn it sideways, make it easy to see. I need to chop this line in half because I'm looking for the midpoint. We don't often get asked to do this, but it's the easiest construction. You need to set your compass to be bigger than halfway. And we make an arc from one end of the line. What's absolutely key now is that you keep your compass exactly the same width, and you come back the other way like so. So we have chopped this line in half. You take your ruler and you join through these 2 intersection points like so. And this here is now the midpoint of the line, which will earn us 1 mark out of the 3. But we need to make a 45-degree angle here. Now, when we've made the midpoint, we've actually already made a 90. So what we need to do now is chop this angle in half. I'm going to use the X factor method that we talk about. So I've got my first curve there, any width. Let's make the next one slightly bigger, like so. So we start to get this donut shape moving around here. And then we draw our lines. So the outer one to the inner one, and the inner one to the outer one. And then where our line goes through, I made a little mistake. I should have gone from there to there. Just here. Go all the way through. And we've made a 45-degree. Just notice my mistake, I went to the wrong intersection point there. I should have come all the way down to this one. Okay. Express 396 as a product of prime numbers in index form. So this is factor tree. Now 396 is quite a large number. I could start by halving because I know that it's even. But I know that I can try any sort of prime numbers, 2, 3, 5, and the number 3 jumps out to me because 3 I can see goes in 1, 3, 2 times. So instantly I know that 3 times 1, 3, 2 makes 396. At this point I'd be inclined to go for 2, and 2 into 1, 3, 2. 2 into 13 goes 6, 1 remainder, 2 into 12 goes 6, so it's 2 times 66. Which is 11 sixes, 11 being a prime number, and 6 is 2 threes. So 396 equals 2 times 2 times 3 times 3 times 11, which is 2 squared times 3 squared times 11. It says y squared is the smallest square number that is a multiple of 396. Write down the value of y. Now this is testing that you understand what can happen when you do your prime factorization. If you can put your primes into 2 equal groups, then you've got yourself a square number. Now if you notice, we had a 2 and a 2, so one can go there and one can go there. And we've got a 3 and a 3, but we've only got one 11. Basically we'd need another 11 to go in there, and that's what it's looking for here, is to write in there is that 11 is the last number that can go in. 11 times 396 equals y squared, but that number then would be 2 times 3 is 6 times 11 is 66. So y squared, y would be 66 if we multiplied 396 by 11. Express 8 to the minus 1 as a fraction. Well, a minus power just means 1 over. So it's 1 over 8 to the 1. And 8 to the 1 is just 8. Calculate 3 times 10 squared times 1.2 times 10 cubed. Give your answer in standard form. Now you can do this all in one go if you prefer. I know some of you prefer to change the numbers first. 3 times 10 squared would be 300, and 1.2 times 10 cubed would be 1200. 3 12s are 36, add on your 4 noughts, and then that's 3.6 times 10 to the 5. You could have done that by doing 3 times 1.2 is 3.6, and then adding the indices of the 10 squared and the 10 cubed. And then express 5.4 times 10 to the minus 3 as a decimal. If we write a load of noughts to start with, just to help us out, and then 5 and 4, we know that the point is there, but it needs the number needs to move so that the point will be placed to the left of these numbers 3 times. 1, 2, 3. So I can forget about those, and I know my number is 0.0054. The probability Daisy wears a bracelet is 0.7. The probability Daisy wears a bracelet and wears a necklace is 0.63. That's absolutely key. For Daisy, wearing a bracelet and wearing a necklace are independent events. That just means there's equal chance of that happening regardless of whether she wears a bracelet or not. Question A. Find the probability Daisy wears a necklace. Now if we look at the diagram, the 0.7 has already been given to us. We do not want to write the 0.7